Hello, how are you? Welcome. Yeah. Um, I tried a lot of things. Um, I tried a lot of things, and I'm just actually sharing with you all my findings here. So first of all of these things should be starting from the data exploration. We got the data last video. We got the data from Kaggle, and we have saved it in this file. And we are going to do a simple kind of exploration on these data sets. And this is the exploration. For that, we need the OpenCV and matplotlib to actually plot them. All the other things were already in the in part of the um, main project directory. It will be here always. Yeah, you can see these pandas, Kaggle was there already, PumpY was there. So we just needed the matplotlib, which is not important for the training stage. So we haven't actually included it here, but we have other things like OpenCV is important for both the exploration as well as the um, what do we say uh, for data training and manipulation. OpenCV is basically a library for manipulating images. So what I would say is that if you have a couple of images, you want to do a couple of things on that images, um, OpenCV is the right guy you had to go into. And uh, the the, the features of why OpenCV is good is because it has a lot of advanced image manipulation techniques. It has techniques for efficient face recognition as well. So it's not actually important in our case, but it's a very advanced library, and I'm very comfortable with using it. Um, Most people actually uses the pillow library, which is called PIL. So the PIL library import the image module, image class or something like that. So if we need an image, we just do is that just do this kind of things. And we have something kind of this one, and we have JPG. That's it. This is the thing, and we can just do the image show here. uh, there will be something issues here. Just JPG. Oh, okay, that's not the issue. I will get this issue done. Yeah, we need to put this here because our directory was in the same place, because our working directory it's in here and it's in the artifact. So when we give the path like this, it's not in this. We cannot find artifacts in the same folder, isn't right? Yeah, should work right now. You can see here the images have been shown, but this is not very good. I don't like this way. And if you want to convert into RGB, it will be done RGB. That's not the thing. But that's not the entire thing here. We just needed the array. Okay, that's it. Yeah, I forgot how these things actually work. Okay, and JPG file get image array. So yeah, so we just needed to get this thing. So this will give us the array. So this doesn't give us the array. PIL doesn't give us the array, it gives the image. I guess so. There is something. PIL get array, image get array, numpy array, how to convert into numpy array. And where do we get this thing? Where do we get this thing? Where do we get this thing? Okay. Hmm. I don't know. Not seeing exactly how. So I just do this thing. I just needed to do few important things here. So just do as per this one dot get data, and I think so it doesn't have things like that. And if we have numpy here, okay, if we have numpy here and p dot array, wow, this is good. And this is what we needed. So we have an extra process to actually do those things. But in CV2, in OpenCV, we just do the CV2 library and we call the CV2 image and we just call just read it. And you can see these images. There's a difference between them. And I don't know why that is, because it seems like each of them it's RGB format. Maybe it's like that, or BGR. Maybe we can understand how PIL reads data in RGB or BGR. Okay, it's yeah, you can see that PIL reads the data using RGB and OpenCV reads data using BGR. This is a BGR format. So just CV2 convert color. You can see this image as being like absolutely same. Now you'll be wondering, isn't both having a two-step process? Absolutely, but CV2 is much more advanced and it has a lot of is optimization as well. So it's a very easy library. It's not an easy library, but it's a good way to start it, because when we go into advanced computer vision projects, you don't have chances to you can use PIL, but CV2 is much more handy, much more, because CV2 gives us the entire manipulation techniques out there. You will understand it when I get into some of the exploration here. Okay, so our data is in this folder, this artifact folder, and so this is the entire data directory. We specify, we just get we just give, we just load the trainer CSV files and see what's happening out there. And when we did the manipulations we had, when we did convert the data set from the raw format to this format, we already had all this information, so we can just view them. Maybe we can just see the head of this one. You can just see this was the actual ID, the video ID, file, the frame ID, and we just created the file name from this one. We have the information like acceleration speed, angular velocity, blah blah blah. All these informations were there. I tried to understand what this object size was and the position size it was, but I didn't want it to happen because this information, this vehicle info, I didn't make use of it because all the cases, not all the cases we have this information. So we don't want this information to have, or we don't want this data set to actually incorporate this information. But here's the thing. This is just the vision part of the project. Might be, if you are interested in, we will go for the integrating multiple features, not just the images. We will actually incorporate this acceleration parameter into the network and predict the crash detection. Maybe could be anything, and that's something is what we have to do in future. But right now we don't have to be bothered about it, and, and we don't have to be bothered about it. So yeah, here's the thing. We're taking multiple features and doing exploration based on it. So I'm taking each videos, okay, I'm taking each video, understand how the acceleration is getting um getting changed after. This is very difficult to understand, so we're just gonna take a small part of it, just 10 videos, to see how does it actually differ from this one. So you can see, and just a small thing. We just need it like alpha. Yeah, the red represents crash situations, and the blue represent the crash, non-crash situations. We cannot be very certain about this acceleration thing because you can see this one. We cannot actually distinguish between all these things. From these 10 samples, we can understand that most of the cases, if the acceleration is increasing, it's going to be increased. So if it's decreasing, it's going to be decreased, or it will be much more flatter. We cannot get any kind of this one. The non-crash situation has a much more variant kind of behavior. It actually get up, down, go around. All these features were there, and you can understand that we were doing the scaling as well. We were scaling the um, values as well around 0 to 1, so we don't have to, how do you say, we don't get. Okay. Oh, there's one single mistake I just did. um okay, we're going to do based on video, and that's one of the things, because here you can understand that things were, mm, I don't know how do I do that, but so we need to get the samples. We can just take the samples. For that, for the samples, just see the samples. I don't understand what we are going to do. We just needed to group by vid, and I guess so this will work. Normalized feature, 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 and this one is going to be happening. Absolutely amazing. This is acceleration. Mm, Here, there's no acceleration. Seriously, I don't understand. Okay, I don't know what's the minimum one or the maximum one in this one. I don't understand what this doing. I will do it my way and way. I would call this thing the feature, acceleration feature. It's going to be feature min. The feature would be done using this one. Okay, this is the way we do it instead of this one. We're going to do it using this manner. Samples, 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 samples. Okay, good, good. So you can understand that in this case, the much more fluctuating, I guess so. I don't understand, but the behavior of acceleration is much more random, not much smoother. If we could understand this, this is way too much, right? It's too much. Maybe I can just reduce it to like three. Oh no 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 no. We can reduce it to the three. Understand that we cannot claim that it's much more unstable. That there is a lot of unstable situations there, so we can identify those things and reach a very good of accurate and good accuracy. I will come to that, but this is not the entire thing. We want to see that this is the entire thing. We want to see the differentiation, the rate of change between all of these things, and from this we can understand that the rate of change in an accident case is much more bigger. Okay, we can understand that from here, from 10 examples. Maybe this is very hard to understand, so we just do this thing around. It's just one case there where the uh, the um, the non-crash situation had a lot of fluctuation, but you can commonly see that accident cases has or crash situations has a lot of fluctuations. Okay, I don't know how do I take this thing to the next level, but um, what I did is that I just needed to know. I just needed to know how does the last frame, how does the last frame contribute to the final solutions. I don't know how does that work, but maybe you can do this thing for 15th frame. The 15th frame, how does the 15th frame contribute to the maybe we don't need this thing at all. You can see this thing. No, I don't see any kind of you can see the cases where the acceleration was higher, still we managed to get lot of things. But this is just 10 samples, so we have to do histogram on a lot of samples, so it will give us the idea about how does it work, how does it actually give us the option to do. And maybe we should do this thing as well. Maybe green, not too much color. Oh, just too much information inside of it. So getting overlapped as well. I don't know how do we give this thing, but this will give us the differentiation, the rate of change. The rate of change actually gives us that both green and red always gives us the same way. As you can see, the distribution is going absolutely the same way. Absolutely the same way. But there's one thing. It's video level. So the video might be in the video the acceleration could be very slow. The acceleration could be very low. The max value is very low. And it will be scaled according to it. So it's not maybe a very good way to scale the functions. I would do it to the entire values at once. I don't know how does it end up, but you can see that in all the cases the acceleration green, the non-crash situation never very rarely goes to the upper half of the acceleration zone. And if you just look into this rate of change map, it's mostly green will have the non-crash situation will have zero acceleration rate of change across the situation across the 20 frames. So it give us a lot of information. But the distribution of all the frames are very, very equal. Let's do the speed for the speed as well. Let's do it for video by video samples. We can understand how does it change. And I didn't do it prior. And see, this is very random. I don't know how does it work. I don't know. You can just see how the representation gives us back. We can see that how situations where rate of change is a lot of same things, and you can see the situation. This distribution is very much common. You cannot actually distinguish between them based on speed as well. So we just do it for the entire video, and you can see how does it end up being. You can see there are certain situations where this apart from the a lot of situations when the speed is higher, the crash is so much lower. And this is the situation where this 0.35 is 3233 or something. That moment onwards, the crash situation is very much common as well. You can see this thing, the rate of change is much higher in case of there are situations where this happens. But here's the, you can see from this data that from this thing we can understand that from the 10th frame about 15th frame the distribution is the same. So what we are going to do, we are going to take this situation into to our opportunity. But when they see a lot of situations, this the 18th or the 16th feature was very much important. I don't know how does it important in this case, but maybe we can utilize those things, but I don't know. Okay, I just did this one. This was one of the previous. I just tried it. And we can just do something like this one. 0. This is 0.1. Here's 0.1. So this will be 0.15. We'll call this 0.15. 0.15. And it will be this one. 0.15 to 0.3333. We will call this thing random. Yeah, we just do equal probability of predictions out there and do 0.548 random values of this one, and for this one it's going to be 1, and this is going to be 8, 8 and 9, 8 and 2, till the 0.7 to 0.7 or 72. Prediction should be less than 0.72. Until that situation it will be random 0.5, or the situation should be 1 because there's no cases where you can see the accuracy has been 0.58. That's not good, but it's okay. We are not going to be using these solutions and they very uh say let's see how delta 0.58 can understand it all from this one situations, speed situation, all these things were different. So we can understand that the baseline right now we have is 0.58, the zeroth column. I mean the The positive situation has an F-con score or recall score of 0.56 because we should always get recall. It should be very higher actually. Or else we end up in a situation where the prediction predicts the non-crash situation and we end up in a non-crash situations. Right now I'm going to show how CV2 library is very important for your manipulation tasks. Okay, that's it. I just have to go right now. I will come out after a few minutes or something. Uh, there's a situation here.